We're going to use the cross product now to find the area of the parallelogram that has vertices P at 102, Q at 333, R at 758, and S at 527. I'll briefly show you how you would plot these points. P has coordinates 102, which means 1 unit out on the x-axis, 0 units for the y direction, and then 2 units up in the z direction. And so that point would exist here over the point in the plane 100. To plot, for instance, 527, I would go 5 units out on the x-axis, 2 units in the y direction, and then 7 units up in the z direction. And that point would exist above the point 520 in the xy plane. Rather than drawing all of these points out though, I've used GeoGebra. GeoGebra has a 3D graphing tool that comes in handy for graphing things in 3D, as you may have imagined. So we have here the points P, Q, R, and S, and they form a parallelogram in space. As visual aids, I'm going to show you where the shadows are in the XY plane of each of these points, just so you get a sense of where they exist in space. Now, drawing this is pretty challenging, but having the visual is fairly useful in determining what the vertices would be for the parallelogram, which is important because we're going to form two vectors. The area of the parallelogram is given by, if the vectors are A and B, the magnitude of A cross B. So we need vectors A and B, and it wouldn't do to use a diagonal. I'm going to label our points here R, S, P, and Q, just so I have handles for them. And I'm going to make one vector the vector SR, and the other vector the vector SP. Now the vector SR is going to be computed by subtracting coordinates. And remember, it is the terminal point minus the initial point's coordinates. And so SR is going to be the vector 7 minus 5, 5 minus 2, 8 minus 7. So that equals 2, 3, 1. We could have done that in either order. I just decided to do it that way because we ended up with positive numbers. In particular, I try to make the first one positive, and then whatever happens with the other ones happens. Next, we're going to form vector SP. Once I've determined that I'm going to use SR, I kind of have made S the anchor, and I want to form the cross product with the other vector that has S as its tail. SP is going to have coordinates, again now, it's the terminal point's coordinates minus the initial point's coordinates. And I see I'm going to have a 1 minus 5. Well, I already made a decision to make the other one positive, this one negative, whatever. 0 minus 2, and then 2 minus 7. So this vector has components -4, -2, -5. For ease of writing, I'm going to call the vector SR A, and then the vector SP I'm going to call B. Now I'd like for you to pause the video and find the magnitude of the cross product A cross B. Keep in mind, you're going to have to find the cross product first and then the magnitude second. For the cross product, we got 15 plus 2i minus 10 plus 4j plus -4 plus 12k. So -13i plus 6j plus 8k. The magnitude squares those numbers and adds them together. We get a result of 269 in a square root. So the square root of 269 as the area of this parallelogram.